Good morning, everyone. My name is Gabriel Marzinotto. I'm a master's student at Telecom Sud Paris. And I'm here today to present you the work on age and handwriting that my colleagues and I have developed at the university. Okay, first, I'll explain what's our objective here. I'll say why it's interesting to study handwriting and why we believe it's correlated with the age. Then we'll see briefly into previous works, and I will proceed explaining our approach, the feature extraction process, and what we call the two-layer scheme. Then some experiments and results, and finally the conclusions and perspectives. So what's our objective here? We are looking forward to study the link between age and handwriting for future characterization of the normal changes in handwriting due to age from the changes due to early pathologies. This means we are going to study handwriting, and we are going to find what we would call a normal deterioration of handwriting due to age. So, but we have not said why it's important to study handwriting. We know that it's a fine motor task, and we know that it's intrinsic of each writer. It means that we can even recognize a person from his handwritten samples. Handwriting evolves over the years. We don't write the same as we were a child, and our handwriting will change as we grow old. And finally, it has been proven that handwriting is affected by several disorders such as Parkinson, Alzheimer, MCI, etc. So, when we look into the state of the art in this field, we quickly realize that there are not many studies. And most of them, they are based on descriptive statistics. They use regression methods and correlational methods that they are good until some point, but they have some limitations, as they assume that all the population will show the same handwriting evolution patterns as they grow old. And this is not necessarily true. We know that sometimes we find very aged persons above 80 years old that they are still in good physical and mental condition, and we find also persons that are younger, that they are 60, 70 years old, and they start showing some important loss of skills. So to counter this problem in our approach, we do not necessarily assume that all persons will have the same handwriting evolution patterns. Instead, we seek for elders, or for groups of elders that have common patterns in their handwriting. To do so, we use unsupervised clustering techniques and what we call the two-layer approach, using both supervised and unsupervised methods. So, what do we mean by a two-layer approach? This is here we do the test considering two levels. The first one, where we study words and low-level signal information extracted from them in a writer-independent way, and the layer 2, where we consider writers instead of words, and we use high-level information that is related to stability. We will look briefly what does this mean. And to do the age characterization on both layers, we're going to use unsupervised and supervised techniques. Unsupervised means that we are not going to use the age information a priori to do the tests. We're only going to reveal it to analyze the results. And supervised means that the age information is used through the whole process to characterize the handwriting. As unsupervised technique, we use clustering, and as supervised technique, we use linear discriminant analysis. So, for those who are not familiarized with online handwriting, this is just what were normal handwriting using a digital tablet, for example, a Wacom tablet, those that graphic designers use. And we sample at a frequency that is usually 100 Hertz. And what we're going to acquire is a sequence of points, x, y, and p, through the time that corresponds to the x coordinate, the y coordinate, and the pressure. The advantages of using online handwriting samples over offline is that they gave the possibility to study the dynamics of this process and they acquire also information about the pressure. So let's talk briefly about our feature extraction. For the first layer, we extract what we call dynamic features: speed, acceleration, jerk, time on air, pressure, and also spatial features that are related to the inclination, to the curvature, etc. Here, for example, we can see two words. Two words written at a different speed, the same word, by two different persons, and we're using a color scale that goes from blue to red, low speed to high speed, and the analog can be done for direction and curvature. Okay, at this first layer, we extract 55 parameters to represent each word. At the second layer, the feature extraction process is a little bit more complex. We take each writer, we take his set of words, and we're going to study how they distribute and what's their relative distance over the whole set of words, or the whole database. What do I mean by this? Okay, we're going to extract first the distribution of words over the first layer cluster. This means we're going to take the set of words of one writer and we're going to project them over the first layer to see where they are located. And we're also going to compute what we call the histogram of distance between words. And this is going to be related to the stability of the writer, because sometimes we can have persons that abruptly change their handwriting style from one word to another. And if we want to characterize this, we measure these distances, and we have here two examples. A stable writer, he would have all his words near the same handwriting style, and a non-stable writer, he will have them sparse through the whole set. In this layer, we extract a feature vector of dimension 11. So, for the unsupervised clustering, our objective is to automatically detect the handwriting styles and study their correlation with the age. At the first layer, we're going to perform a clustering of words using the low-level descriptors. This is done writer independent, and in order to do so, we use k-means and hierarchical clustering. Our experiences show that they both give similar results, and for the second layer, something similar is done, but over the set of writers using the high-level descriptors. Here we retrieve another K2 clusters. Okay. For the supervised learning, instead of detecting handwriting styles, we're going to try to reveal parameters that would characterize a certain age group. And to do so, we give the age information as an input of the algorithm. And we wish to find both low-level and high-level parameters that characterize each age group. And we're going to also determine which age groups are more distinguished from the others. Okay, the experiments, they were run using the Iron database, the online part. We extract almost 800 writers from 11 to 77 years old, and each of these have wrote from 20 to 50 words. In order to characterize the age groups, we use state-of-the-art groups, and we divide them into 6 categories. We have one for teenagers, one for elders, and 4 categories of adults, as we see in the table. And the problem is that Iron database is unbalanced, and each categories, A2 and A3, are overrepresented. So to fix this problem, we're going to aim to increase the number of elders and teenagers. In order to do so, we're going to take each person P that wrote from 20 to 50 words, and we're going to split them into kind of virtual writers who wrote from 10 to 15. So if we have an original writer with 25 words, he'll become 2 writers of 13 and 12. And after this, we're going to balance the database to ensure that all age groups are equally represented. At the end of this, we obtain 144 writers that will allow us to make fair comparisons. Okay, results from the first layer. When we do the clustering, we automatically obtain that the best number of handwriting styles at the first layer was 6 using silhouette methods. And when we look what's inside of these 6 clusters, we obtain a typical handwriting styles, 6 of them. And if we observe how they distribute around 3 main criteria. The associated dynamics, whether if the handwriting is fast, slow, or medium, the inclination, if it's inclined to the right, to the left, or if it shows no inclination, and the fact that the writing is script or cursive or mixed. So these are the styles, and if we look at some words, we can see that some clusters show very pronounced difference. For example, we have cluster 5 that has very fast handwriting and cursive, in contrast to cluster 2 and cluster 3 that are mostly script and very slow handwriting. So these are the first layer handwriting models. And when we proceed with the second layer, we perform once again the clustering and we retrieve 8 categories of writers. And then we want to look which categories have the larger concentration of elder and teenager population. And we see that for elders, in categories C2 and C7, they appear overrepresented. And when we look what characterize writers in C2 and C7, we observe that C2 contains very slow handwriters that show average stability. And in C7, elders show a faster handwriting, but also with a very large instability. For teenagers, when we do similarly, we observe that teenagers have a very slow handwriting, but that comes with a high stability. Okay, so here are some examples. We have an elder from C2, one from C7, a teenager from C1, and an adult from C6, which is a category that contains almost no teenager or elder. So for C2 first, we see an stable handwriting style that is very slow. Here we're showing in color the speed of the handwriting. The elder in C7, he has a faster handwriting style, but also he's more unstable. He shows curvature through the words. The number of pen-ups is not constant. And for the teenager, we see a very stable handwriting style, also very slow. And for the adult, he's both stable and fast. So, in order to quantify the effectiveness of this clustering, we introduce an entropy efficiency measure. It's a normal entropy, but it's normalized by the number of age categories. And if we want the short story, it's a number that goes from 0 to 1, and it takes value 1 when the age groups are equally distributed through the clustering, and value 0 when the relation cluster to age group is 1 to 1. This would be the ideal case, where knowing the cluster of a person would automatically help us to determine his age group. Okay. So, when we compute this entropy across our 2-layer approach, we observe that each layer shows a decrease in the entropy. This means that we are getting better at grouping the ages of the writers. Moreover, when we look into the categories that we said contain the elder population, they are also the ones that show the lower entropy, which means that we're getting better at classifying the elders' handwriting style. As for the supervised learning techniques, we use the LDA, as we said, and we first try to use pairwise discrimination. This means we put the 6 age categories and we try to see how much we can separate them. Right? So, in the table we have the classification errors, and we observe that elders are the easiest person to distinguish. It doesn't mean it's easy. It doesn't mean we don't make a classification mistake, but they show a lower error, which makes that their handwriting style is different. And also very interesting, groups A2 to A5, which are adults, they are the most difficult to classify, and this implies that the handwriting style does not seem to change very much through the adult stages. Okay, when we look to the parameters that allow distinction of elder, teenagers, and adults, we see that elders show less pen pressure than adults, and that for teenagers and elders, they present more pen-offs, they have a larger time on air as they write, they also tend to use more straight lines, and they use more horizontal space. And for the second layer, we see that elders are characterized by a large variability, and they are represented by the clusters C3 and C5 from the first layer. This confirms the results that we obtain in the unsupervised approach, because we can observe that we have cluster 3 and medium variability that would correspond to category 2 of the clustering algorithms, and we have cluster 5, which is fast handwriting, that will come with high variability. So this kind of reinforces what we obtained in a non-supervised way. To conclude, our two-layer approach uncovers different handwriting profiles through age. For teenagers, it says they have a stable and slow handwriting. For adults, they have average stability regardless of the handwriting style. This means we have adults that write fast, medium or slow, and also cursive, mixed or script, but they always are equally stable. And their handwriting style doesn't seem to change from people between 17 and 59 years old. And for population above 60, we can split them into 3 tendencies. One, the first one, they show a decrease in the stability. It means they tend to change across words, the handwriting style. The second tendency is a decrease in the speed and the associated handwriting dynamics. And the third one, that is less frequent, but also appears, is no decrease in the stability or speed at all. This would be the persons that they keep all their skills as they grow old. And we have to say then that we developed several handwriting patterns for elders instead of one, which was our objective. And this entropy efficiency measure that we include is confirming the results that we're getting better at characterizing handwriting style of elders. Finally, some work in progress. We are increasing the number of aged persons in our database. Here we can see the original database is on blue. The elders from this original database are on green, and the new insertions we recently made on red. And we can see that the results are verified, and these new persons that we include, they fill the same spaces that the previous elders, and they all fit in category C2 that corresponds to slow handwriting and an average stability. Also, further work to do is to include persons with psychomotor disorders. To do so, we are starting a collaboration with Hôpital Broca in Paris, and we are targeting disorders such as Alzheimer and mild cognitive impairment. So these are the references we used for this presentation, and if you have, thank you very much for your attention. And if you have any questions, I will be happy to answer.